this says, in the real world, so outside of high school, there's Algebra 2, linear programming is used all the time. We kind of mentioned that yesterday. I said in jobs that deal with production, like making things, and profit, so business, when you want to make money, they will use linear programming. They're not going to do it like you're doing it by hand, but they will create equations. So in your job in real life, you might have to create an equation one day. I know, like it's so horrible. You might have to create an equation to ensure that you're making the most money. Because really that's what businesses do. They want to make money while also not losing money. Right? So our job today is just learn how to create those equations. Because the setup and the structure might be a little bit different than things you've seen before. The key to being successful here is staying organized. I'm going to show you, like I make a table when I set up these equations. I will show you how I do that. You don't have to do the table, but at least today, until you find your own strategy, try the table. If you like colors, colors are great. If you don't, that's okay, but at least use some structure to keep organized here. All right. So we're going to start with an example about baseball bats. So Super Bats is a company that makes two different kinds of wood baseball bats. Right? They make one kind called the Homer Hitter and one called the Big Timber. Then they give us a bunch of information about the Homer Hitters and the Big Timbers. They tell us the Homer Hitter takes 8 hours to trim, so that means to make the shape, like to cut, and turn on the lathe. The lathe is the machine that does the cutting of the baseball bats. And the Homer Hitter takes 2 hours to finish. That'd be like sanding and putting the stain and the paint and all that on. And each Homer Hitter makes a profit of $17. They give you the same information about the Big Timber. It takes 5 hours to cut, 5 hours to finish, and it makes a profit of $29. Okay. Then they tell you some information about how long they have to work, because in real life, you don't have an infinite amount of time to make something. Like there's got to be a deadline. So they take 80 hours to cut bats, and then 50 hours to finish them. That's the most that they have here. Now here's the sentence that we start with every time. How much of each kind of bat must you make to maximize the profit? Our first thing that we go to when we do these kind of problems is looking at the money. Where's the money taking you? Well, money is about profit. So we're going to jump down to part B here, because I always start with this. It's called the objective quantity equation. That objective quantity is what your end game is. What is your goal? Well, our goal is to find the profit. I want to know how much money do these bats make me, because then I know how many I have to produce, how many I actually have to manufacture. So we are going to start with talking about profit. Now we're finding the profit from a couple different things. We need to figure out, in order to write this profit equation, we need to figure out what our variables are. That's what it's asking us in part A. We're going to need an X, and we're going to need a Y. So we need to think about what it tells us to find the profit of. Well, it says find the profit of each kind of bat. So what kind of bats does this company make? Homer Hitters. So let's make X Homer Hitter. And the Y will be the other kind of bat. That's the Big Timber. I know, they're great names. I did not write this down. Now, do you think it matters if I switch the X and the Y? No, it doesn't. You will end up getting the same answer at the end of the day. So we know X and Y. So now that I've figured out my variables, because I know what I'm making a profit of, I can write the profit equation. So let's think about the Homer Hitter. Look back up here. And what does it say that the Homer Hitter makes you in profit? 17. The Homer Hitter makes a profit of 17. So we're going to put that in our equation as 17x. $17 per Homer Hitter. And then I'm going to talk about the Big Timber, my Y. How much profit does the Big Timber make you? $29. So we'll say plus 29y. Now that's your equation, but we have to be at least a little bit formal about it, meaning that we have to put some kind of notation out in front, right? It's not an equation without an equal sign. Well, yesterday we did f of x. So f of xy. Today, since we're talking about profit, we're going to write p. P of x and y. That just means what's the profit from both of those variables together? How much money does Superbats make? So that's what I start with. The profit equation should be pretty much the easiest part of this whole process. We can look, it'll always say it makes a profit for this and this. Find your variables, write the equation. Now we have to deal with all the rest of the numbers up here. Generally, you're going to use all the numbers that are up there. That kind of helps you keep track of things. But we need to write a system of inequalities. Remember I said yesterday that system is called constraints. Those are rules. So we're going to write a couple of equations. Here's how I keep organized. We're going to create a table. The table is going to be the same every time. There's going to be 4 columns. And along those columns, the first one, I'm going to write the word topic. Now, topic is going to be just like, what is the equation about? Because we're going to label, I have an equation for this, an equation for this. Then the next column is for x's, your x variable. A column for your y variable. And then a column I'm going to call the total. Okay, so every time you set this up, those 4 columns need to go along the top, and you're going to end up with usually 2 rows, sometimes 3 rows, but 2 rows. Now, just because it helps me stay organized a little bit, above the X here, I'm just going to remind myself that that's my Homer header, because sometimes it's nice to see it right above your table, and the Y is for your big term, so you can just abbreviate. Now, I need to fill in that table with information from those bullet points up above. So let's see. I need to figure out first, what are the topics of my equations? I can't write an equation unless I know what I'm writing an equation about. What do you think, Bobby?
One would be hours for trimming and aging.
Yeah. Yes. So you look at, once you find your variables, which are the Homer header and the big timber, you think, what are they telling me about those bats? Well, for the Homer header, it's giving us information about how long it takes to trim. I also get that information about the big timber. So if I get 2 numbers about the same thing for each variable, that's going to be 1 equation. So one of your topics is going to be time to trim. You can just put trimming there. And the body said the same thing for the other equation. He said, we have information about finishing for both. So once I know those numbers, or know the topics, I'm going to fill in my table with the values. So what does it say for the Homer header? How long does it take to trim? 8 hours. So I'm going to put an 8 under the X column for trimming. Alright, how long does it take to trim the big timber? 5 hours. So it takes 5 hours to trim. So I'm going to put a 5 under the Y. And then let's talk about finishing. How long does it take to finish the Homer header? 2 hours is up at the top there. So I'm going to put a 2. I need an equation for finishing. Put 2 under there. And then how long does it take to finish the big timber? For 5. Okay. So we got that. Now I'm going to use those numbers, and I'm going to end up turning that into equations. So in order to have an equation, I need symbols and variables. So the first thing I'm going to do is let's add some variables here. Under the X column, you need to put some X's. And then under the Y column, you're going to put your Y's. Now again, this is an equation that we're coming up with. So I'm going to put a plus sign in the middle. I need an equation. It takes 8 hours for the Homer plus 5 hours for the big timber. It's not a long day to talk here. So we put plus signs in there, but then I have to deal with the total and the other symbols. So it gives us some information up above about how much total time Superbats has to trim the bats. What does it say? That's your last bullet point. The total time available for trimming is 80. So that's going to go under your trimming total is 80. How much time do you have available for finishing? 50. So we need a couple more symbols here though. So let's think about the total amount of time. If you're trimming, could you spend theoretically less than 80 hours trimming the backs? Yeah. Could you spend exactly 80 hours? Yes. Yes. Could you spend 85 hours? No, they only are allocating 80 hours. So we need to put a symbol in there that tells us what we just talked about. I can be less or equal to 50, but not, or 80, but not bigger. What symbol would you put in there, do you think? Less than or equal to. These are going to be inequalities. Same thing with finishing. I can be under 50 hours to finish, or equal to 50, but I can't do more. Yeah. So those are what's going to be our equations for our system. So let's write our system. Our system goes in curly brackets. So I have 8x plus 5y less than or equal to 80, and 2x plus 5y less than or equal to 50. Now today, we're stopping there. Tomorrow, we're going to end up solving those for y, graphing them, and then finding the actual profit and how many backs they have to manufacture. But today, we want to set them up. But there's one more box at the bottom here. Right? It says, well, not explicitly stated. I didn't actually tell you this, but while it's not stated in the problem, it is understood that you can't make a negative number of baseball bats, right? So, with that being said, we have to actually add 2 more inequalities to our system. We're going to add every single time, not just this time, but every problem. We want to say x is greater than or equal to 0. What do you think that means? What's the x? What do we say x was? Homer hitters, right? The homer hitters, I can't make a negative number. I can make 0 bats, right? And I can make positive, but I can't make negative. And we also have to add the same thing for y here. I can't make a negative homer hitter or a negative big timber bat. So those actually get added into your system of equations. So when we do graph this tomorrow, we'll have 4 equations to graph, which will be 4 lines. So that's pretty much the process you're going to follow. Some problems we'll do a different one here in a minute. Some will be a little bit different, but that's kind of the start. You good so far? Okay, let's go to the next one. Now we're going to talk about cars and trucks. So an automobile manufacturer makes cars and trucks in an assembly plant, and this factory is divided into 2 shops. The first shop assembles the car, and it gives us some information about how long it takes to assemble the cars and the trucks. And then after you're assembled, you go to the second building, the second shop, and it does the finishing touches. Okay. Now, again, I'm not reading all this information because I know you guys can read. But we always look for the money first. Go to profit here. The last bullet point says the profit per car is $500 and the profit per truck is $700. That profit equation helps us figure out what our variables have to be. It tells us what 2 things I need to add up to get my profit. So what do you think my x should be? And what do you think the y should be? Cars. All right, we'll make x cars and we'll make y's trucks. You can flop them if you want. I think last class we flip-flopped those. So you have cars and trucks. Now, we need to write our objective equation. Again, that's our profit equation. So your profit for x and y, for cars and trucks, is what? Well, how much do you make for a car? $500, so 500x, plus the profit of 700 for all the trucks. That's the easy part. Finding x and y is not too bad. Figuring out your profit equation. Now we need to write our system. So this is where you start by setting up your table again. Every time, start the same way. We'll have our topic of our equation. We'll have our x value, our y value, and the total amount. of something. And then we'll have a couple equations over here. All right. So really, I think in the past, what's been hardest for people is figuring out what your equations are actually talking about. So let's look here. What do you think one equation might be about? What information do they give you about cars and trucks? What do you think, Jamie? Assembly time, yeah. They give you two pieces of information. They give you how much it takes to assemble a truck and how much it takes to assemble a car. We got two numbers for it, so let's make an equation about assembly. How long it takes to assemble. All right, what do you think the other equation should be about? What other, we gave you more numbers. What are these threes about? What? Yeah, 3 worker days to finish. Do finishing touches. That's like paint and polish and stuff. So we're going to have an equation about finishing. So then how long do we have to build the car, and how long do we have to make it pretty? Well, let's see. Let's write our equation. How long, so X was cars. How long do they give to assemble a car? 2 days. So we'll put a 2x under the column for cars. Then how long do they give us to assemble trucks? 5 days. So we'll have plus 5y. You can go and just add those pluses and stuff now. Well, total, we need a total number. How long in total does this company have to assemble cars and trucks? 180. So first shot has 180 days, worker days, to assemble trucks. Now what symbol should go before the total value here? Less than or equal to. I can use less than 180, but I don't have enough manpower to spend more than that amount of time. All right, so that's one equation. Our second equation is set up the same way. For cars, how long do we have to finish a car? Make it pretty. 3. So I have 3x. Well, how about a truck? How long does it take to finish a truck? 3. Why? Is less than or equal to how many days? 135. All right. So those are my two equations. I need to put that into a system over here. So you make your curly brackets and rewrite them. 2x plus 5y less than or equal to 180. And 3x plus 3y less than or equal to 135. And what am I missing? X is greater than or equal to 0. You have to write those down. If you don't, you're technically missing two equations. I know, like, we take it for granted, but you can't have negative cars. You can't make negative terms. So there's your system. All right. Now we need to do the third one. I know, like, it seems pretty easy when I'm doing it basically for you, but this next one's different. Number 3 is a different system. And also, it doesn't hurt to see it again because it's a little different doing it on your own in a few minutes. So let's see. Stitches makes 30 jean jackets and 20 leather jackets in a week. Or I read that wrong. Can make at most 30 jean jackets and at most 20 leather jackets in a week. So they make jackets. We are starting with figuring out what are our variables, right? They tell us the number we can make and different things up there, but we skip right to profit every time. That's where I want you to start. The profit on a jean jacket and the profit on a leather jacket. Well, what two things do I get profit from? Jean jackets and leather jackets. Because I make profit from those two things are my variables. So I'll make profit on my jean jackets and profit on my leather. Those are my X and my Y. So then that objective quantity, that's your profit equation, comes from that last sentence. It's usually the last sentence here. How much do I make for a jean jacket? 20. So I have 20x plus how much for a leather jacket? 50y. objective quantities there. This system's going to look a little different. So it'll pay to pay attention for 4 more minutes or so here. Right? The table is set up the same way, always the same. You have a topic, your X, your Y, and the total amount that they give you. So let's look up above. The first sentence says that they can make at most 30 jean jackets, and at most 20 leather jackets. And then the second sentence says it takes a worker 10 hours to make a jean jacket and 20 hours to make a leather jacket. From those two sentences, what do you think your equation should be about? Hours? Is that what you said? So hours to make. So that'll be one equation, an equation for hours. You can just put hours, but I'll write it. Hours to make a jacket. And what else do they give you information about? Because hours to make is the second sentence. We have hours to make. What other numbers do they give you? What'd you say? The amount they're making, yeah. So they give us the amount of jackets that are made, right? They give us numbers for that. That's the first sentence. So the hours one, that's going to be pretty easy to write here. How many hours does it take to make a jean jacket? It says 10 hours. Ooh, I just wrote right through that. It's 10 hours to make a jean jacket. So I'll do 10x right here. Well, how many hours does it take to make a leather jacket? 20y. So plus 20y is less than or equal to the total number. How many hours at most can stitches make jackets? Employees can spend no more than 500 hours per week. All employees combined. Because there are not 500 hours in a week otherwise. Yes. They're like in a different time continuum than we are. Yeah, so we have that equation. Now this is where things are going to be a little bit different. Let's look at the first sentence. Stitches can make at most 30 jean jackets. And they can make at most 20 leather jackets. Right? These equations are going to be different than this. Because really, these are the only two numbers that are left. I don't have a total number left over. So what this means is I'm going to have a couple different equations here. I'm going to have one equation just for jean jackets. And it's going to say the jean jackets, which are X, are less than or equal to 30. That's going to be one equation for you. The total number of jean jackets you can make has to be less than or equal to 30. Then, can you come up with a similar kind of equation for leather jackets? Yeah, y is less than or equal to 20. Now, I don't have a total this time, so you can just cross off the total box here. Sometimes it's going to look a little bit different. Not always going to be exactly uniform. They don't really care total how many they can make. They just don't want to be over those amounts for either jacket. So we're going to set up our system. We're going to start with 10x plus 20y less than or equal to 500. And then I don't want you to write anything yet. After you write that equation, I just want you to wait. I'll tell you when to write. We also came up with these two equations. So our next equation is going to be x is less than or equal to 30, and y is less than or equal to 20. Those are the three equations we came up with. What were the other equations I'm missing? Yep, you're still not writing, so just watch for a second. So I still have to add those equations in. But notice I have a x is greater than or equal to 0 and an x is less than or equal to 30. Can you think of a way that I can combine those together, Andrew?
Put the 0 right there.
Yeah, with the less than or equal to. That combines this inequality with the other one. And I can do the same thing for leather jackets. 0 is less than or equal to. You can write this down. So those are those compound inequalities like we were seeing when we graphed today. But really that tells you, okay, I can make a positive. I can make 0 or up to 30 jean can't be negative and it can't be more than 30. Same thing with leather jackets. And that would be your equation. Okay? You okay so far? So, your quiz tomorrow. I want you to sit here for